chemical bonding, and intermolecular forces, chemistry. So we are going to look at it in two parts. The first part of the lesson is going to be chemical bonding, and the second part of the lesson, intermolecular forces. Yes, chemical bonding, and then the second part, intermolecular forces. Under chemical bonding, in fact, so I'm going to start with one. Chemical bonding. Chemical bonding. Yes. So, a chemical bond, you're writing definition. Yes, chemical bonding is a creation of a chemical compound. The creation of a chemical compound or electrostatic force of attraction or electrostatic force of attraction holding atoms together electrostatic force of attraction holding atoms together in a molecule or compound holding atoms together in a molecule or compound formed either by gaining, losing, or sharing of valence electrons. Electrostatic force of attraction holding atoms together in a molecule or compound formed either by gaining, losing, or sharing of valence electrons. That's the definition of a chemical bond. The next thing we're going to look at is the various types. So just go ahead and write types of chemical bonding. Types of chemical bonding. 1. Ionic bonding. Ionic bond or ionic bonding is a type or a sort of chemical bond in which is a sort of chemical bond in which electrons are completely transferred from an atom or molecule to another. Okay. Ionic bonding is one of the type of chemical bonding, and this type of bonding is characterized by a complete transfer of electrons. So in an ionic bond, there is transfer of electron from one atom to another atom, or from a molecule to another. So an ionic bond may occur like this. Let's say we have an element, an atom of an element represented by A. this element here can lose an electron. Will lose maybe an electron, and by the time it loses an electron, it is forming an ionic bond. Meaning that when you lose an electron, you are giving that electron to another atom or another molecule. So by the time this electron goes now to that molecule, this boy becomes positively charged. We call this cation. Now, this electron is received by another species, be it an atom or a molecule, which absorbs the electron and then obtains a negative charge. As a result, it is now called an anion. So this is cation here. Cation. Now the species that absorb the electron is going to be called anion. Now, why does it obtain a positive charge after losing an electron? Electrons are negatively charged. An atom normally is neutral, right? Yes, because for a neutral atom, the number of protons is equal to the number of electrons, so it's balanced. If you have an atom of, choose any element of your choice. So let's say what?
Element. Sodium.
Sodium. Okay. Sodium is element number 11, right? Yes. 281. Okay. So it simply means that an atom of sodium has a nucleus made up of, yes, protons and neutrons here, right? And how many protons are there? 11. It's okay. How many electrons? 11 electrons. So that is why when we are defining atomic number, we say atomic number refers to the number of protons found in the nucleus of an atom. When we are defining in terms of electrons, we say atomic number is the number of electrons that are found on the shells of a neutral atom. If it is neutral, when it's not neutral, a proton number never changes, right? But electron number can change due to electron transfer. Electron number can change. So, positively charged ions are called cations. Negatively charged ions, like this one, they are called anions. So they come by the formation of ionic bond. For example, the most famous ionic compound everybody knows is table salt, sodium chloride, right? Now sodium. In sodium chloride, sodium is atom number 11. Yes, electronic configuration 281, right? Chlorine is 287. So now the question is, why do elements, atoms, why do they undergo bonding? Molecules, why do they undergo bonding? Is to obtain what? Stability, right? Is to obtain a stable octet or duplex structure. Octet or duplex structure. A stable duplex structure is for an atom with just one shell, where it needs 2 electrons on the shell, right? The first shell, which will be the last. But the octet structure 8, right? 8 electrons on the atomous shell. So, in the desire of atoms to attain this stable or this stability, they achieve this objective through chemical bonding, and ionic bonding is one of them. So now, is this one stable? The answer is no. 281. So this boy sees that it is easier, talking about sodium, it's easier to give out this 1 electron than to receive 7 electrons to make it 8. As a result, it's going to be very willing to lose one of its electrons. On the contrary, chlorine needs 1. So you see that it's easy to simply transfer this. When they say transfer, nothing gain, nothing in return. Transfer this electron from sodium to chlorine, and then sodium becomes sodium ion with electronic configuration 2,8, and then chlorine becomes a chloride ion with electronic configuration 2,8. Okay, this is how ionic bonds are being formed. And very soon I'll start talking about the Lewis structure of an atom. The Lewis structure, you know about the dot and cross diagram, that is Lewis structure. And the Lewis structure actually represents these things again. We can do that for sodium chloride. And you don't need to copy the notes. Send it to me. Okay, let's do that for let's say sodium chloride. Yeah, and we are drawing the Lewis structure. Let's say Lewis structure. For the formation of sodium, the Lewis structure is formation of sodium chloride. So if first we'll write the sodium, an atom of sodium. Now, it's preferable you just represent the outermost shell, okay? But normally, sodium was supposed to be like this. Sodium, the first shell, 2, right? 2, 8, 1. But we're simply going to represent just the outermost shell. Yes. And then chlorine. Chlorine. We now use a different, let's say, dots. And then this space is vacant. Now, electron transfer of this electron from sodium to chlorine renders sodium. Yes. You now have one. And then sodium ion with electronic configuration 2,8. And then chlorine. 1, 2, 3, 4, 5, 6, 7, and that electron with a negative charge. The chloride ion now 2, 8, 8. Okay, so this is the Lewis structure with the formation of sodium chloride, and with this you can do for the others, right? We can have magnesium chloride. Yes, magnesium chloride, simply here you are seeing very well. You know magnesium. Yes, it's in group 2. It's 2A2, right? 2A2. So you need to give out 2 electrons. And a chloride atom can only receive 1. So 2 of them, one will go there and this another one will still go to another chlorine. So that is it. You do this one as an exercise. Check it. Okay, so that's ionic bond. Another name for ionic bond is the electrovalent bond. Electrovalent bond. Yeah, good to know. We either call it the ionic bond or electrovalent bond. Alright, before we go to covalent bond, I'll say 2 things. 1, the characteristic of ionic compound, and also the factors that affect the formation of ionic bond. Yes, so those are 2 small things that I'll mention before we go to the next type of bonding, which will be covalent. Yeah, and why be? Say this again. Ionic bonding. This is what happened. A certain atom of an element, say A, it gives out an electron and obtains a positive charge. Now, another atom, say B, now absorbs this electron or receives this electron and forms an ion B with a negative. Now this is how electron transfer is done. This ion here is called cation because it is positively charged, and this ion here is called anion because it is negatively charged. Now, factors that affect, or should I take the characteristic first in a way? Factors that affect the formation of ionic bond. So, those factors, I'll talk about three. I'll talk about ionization energy, IE. I think it's not your first time hearing about ionization energy. I'll also talk about electron affinity. Yes, then I'll talk of lattice energy. So, what is ionization energy? It's not the note, I'll just define it. Ionization energy. It is the minimum amount of energy required to remove 1 mole of electron from 1 mole of a gaseous neutral atom, okay, to form 1 mole of a gaseous positive ion. That's ionization energy. What does it mean? The energy that is required to remove this electron here, the energy that we need is ionization energy. So, an atom with a high ionization energy will need more energy to remove an electron, right? For electron transfer to occur. Then, now for the receiver, the atom that received the electron, now we talk of electron affinity, the love for electron, right? Yes. For example, we saw how fluorine. Okay. Do you know the most? Let me keep it there, please. Ionization energy. We have first ionization energy, second, and so on, right? And then it is simply the minimum amount of energy that is required to remove 1 mole of electron from a gaseous atom or ion, right, to form 1 mole of gaseous positive ion. Now, if it is first ionization energy, IE1, it is a minimum amount of energy required to remove 1 mole of electron from 1 mole of a gaseous neutral atom. Yes, because if this first ionization energy means the atom was neutral and it forms 1 mole of a gaseous unipositive ion. Alright, not to talk much about this because we'll still talk about ionization energy again in one part of chemistry somewhere. Now, so you see that ionization energy is one of the factors that will affect the formation of ionic bond, right? So, electron affinity. How does it affect ionization energy? The greater the ionization energy, then the lower the tendency for the formation of this thing, ionic bond, right? For electron affinity, the higher the electron affinity, the higher the degree or the tendency for the formation of ionic bond. Okay. Yes, so yes, then we have lattice energy. These two, they are okay now. Yeah, lattice energy. It happens in the formation of ionic compounds. That's, for example, if you have a compound like, okay, let's use sodium chloride. lattice energy where you have a positive and a negatively charged ion, right? Lattice energy, the energy between them. So it is also one of the factors that will affect the formation of ionic bond. You can't talk about lattice energy in other kind of bonding. It's only ionic bond that have lattice energy. It's okay. Yeah, I think that's all the factors that will affect the formation of ionic bond. We'll now look at the characteristic of ionic compound. Characteristic of ionic compound. One, they are crystalline in nature. They are crystalline in nature.
Characteristics.
Yeah, we have characteristics now. Come again. Yeah, characteristic of ionic compound, not in bond now. But when now talk about ionic compound, we mean compounds that are formed through ionic bond. Yes. Okay. They are crystalline in nature. They are stiff and brittle. They are stiff and brittle. Why are they stiff? Because they are held together by strong forces of attraction. In fact, known as electrostatic force. In the definition of bonding, I did not really explain what is meant by electrostatic force. Yes, I'll actually explain it now. Okay, so what is the meaning of electrostatic force? Electrostatic force simply means force due to charges. Yeah. Electrostatic means opposing charge. I mean, in fact, let me just simply say electrostatic means charges. Okay, we have positive and negative charge. These are the two types of charges, right? So you know very well on light charges they do what? They attract. Light charges, they repel each other. So there is a force that exists between. The force between charged particles is always electrostatic in nature. So that is why, for example, we are talking about ionic compound. We have an anion and then we have a cation. Yes. So the force between them should be electrostatic. Then ionic compound number 3, they have high melting and boiling point. High melting point and boiling, NP and PP. They have high melting point and high boiling point. They are soluble. Comma, more in polar solvent. More in polar solvent and less in non-polar solvent. It means in polar solvent like water, they are very soluble. But in non-polar solvent, they are less soluble, but then they are still soluble. They are good conductors of heat and electricity. Some are electrolytes. What are electrolytes? When we say something is an electrolyte, it means it can conduct electricity only when it is molten or dissolved in water. Or dissolved in water. Yes. So if that is fine, we'll go to 2. We'll talk about covalent bonding. In covalent bonding now, electrons are shared. So here we have sharing of electron pairs. Sharing of valence electrons. Okay. Covalent bond. Covalent bond has strong electrostatic force of attraction. Please write it down with us in the notes. There are strong electrostatic force of attraction. Strong electrostatic force of attraction between the shared pair of electrons, and the nucleus or the nuclei of the bonding atoms. That's covalent bond. That's covalent bond. Just take a small. No, there's no need. You now see that one in the notes. The difference between, let's talk about a small difference between ionic bonding and covalent bonding. Number 1. What do you think? What differs between ionic and covalent bond?
In covalent bond, both atoms are giving and losing atoms that are sharing.
Okay, in covalent bond. Is it covalent or ionic?
Covalent.
Covalent. Okay. Yes, there is sharing, right? Okay. Why in ionic what happens? There's transfer. Good. So in ionic it's simply a transfer of electron. In covalent is sharing of electron. It happens in real life. We have friends. Yeah, we always have friends in life. And then there are some of our friends you notice they are perpetual receivers. Yes. Meaning that they are ionic in nature, and not just ionic, they are anionic. They are always anions. They are always receiving. So the day you come with breads, you share, you give their own. You transfer, you give their own. The day you come with shawarma, you give their own. And there's never a day you will sit and they will tap you from behind and also give you something. So that's ionic. But when it comes to a situation where today you come with juice and the other person come with this and then you people share together, you come with this, come with that, and you people share. It is now, so if you look at it in real life, you see that human beings are not different from elements, right? Are not different from elements. Yeah. Now number 2, I will say that aside this, ionic bond occurs between a metal and a non-metal. Yes. The metallic atom at the end becomes a cation, positively charged, because they are the ones to give out electron. The non-metal or the non-metallic atom, they receive and at the end they become anions, negatively charged. So it's between a metal and a non-metal. Ionic bond. Yes. So now, what about covalent bond? Between two non-metals. So if you want to see, you want to know the type of bond existing between two elements, two atoms, two compounds or molecules, what you should do are they metals or non-metals? Because if the one is a metal, another one is a non-metal, it's ionic. Clear, no doubt. And if the two of them they are non-metals, then it's what? Covalent. And if the two of them are metal, it's now metallic. Okay. Yes. Let's continue. They have a common similarity. Electrostatic forces of attraction. Let's continue to look at Lewis structure for covalent compounds or covalent molecules. Yes, we are going to start with something like water. Water can be written like this. You have seen this before now. Yes. This thing represents a shared pair of electrons. This is a covalent bond. So when it's like this, a double bond, double covalent bond. So mostly in organic chemistry, where you see bond, you see they represent bond with this. Those are covalent bonds. Okay. So let's draw the Lewis structure. Lewis structure for the formation of water, which is a covalent molecule. So, oxygen has how many electrons on its outermost shell? What's the electronic configuration? 2, 6, right? So I'm going to represent that 6 outside here. 1, 2, 3, 4, 5, 6. It's okay, right? Now, hydrogen. Yeah, is 1. Is 1, 1. So this is what is going to happen. I'll put it like this. 6, right? 2, 4, 5, 6, right? Now, hydrogen is coming to share its 1 electron with this. Another hydrogen will also come here and share. At the end, this is water. Yes, they have shared. If this one came with 1 electron and also share 1 electron of this, it is stable. It has 2 electrons. This one, 2 electrons. This one now has 8 instead of 6. And then it's now stable. Yeah. So even for carbon dioxide, or they say carbon dioxide, and is this CH4? What's the name for CH4? CH4 and it's in what? Methane. It's also covalent molecule. So for CH4 and CO2 is school. So, okay. I think we have just spoken about this thing, covalent bond. Okay. So, now, we are not going to, there are 2 types of covalent bond. Let's look at that. Types of covalent bond. We have ordinary covalent bond, and then we have what? Dative covalent bond. Let me check if I added that thing in the note here. because I'm saying it now, I see the thing is strange. I'm not seeing it in the book, so I'll explain here. Yeah, there are two types of covalent bond. Ordinary covalent bond, this is what happened. In ordinary covalent bond, an example is water, like this thing that we have done here, even methane, CO2. They are examples of ordinary covalent bond. Where the shared pair of electrons come from both atoms. So both atoms, they contribute equally to the shared pair of electrons. And remember, the covalent bond is that force of attraction between the nucleus of the bonding atoms and this shared pair of electrons. So this shared pair of electrons is negatively charged, you know. Electrons are negatively charged. And then these centers, they are positively charged. So there exists a force of attraction, electrostatic force of attraction between them. It constitutes the covalent bond. Now, in dative covalent bond, it is so simple. There is sharing of valence electron, but now, where is this valence electron coming from? The valence electron that's being shared is not coming from both atoms. Yes. So it is either an atom contribute more to the shared pair of electron, or a single atom comes with the shared pair, the electron pair, the other one comes empty, then they share. It constitutes dative covalent bond. Okay. Now, assignment. Conditions for the conditions necessary for the formation of dative covalent bond. There are two conditions. Sorry. There are two conditions necessary for the formation of dative covalent bond. And then three limitations of Lewis structure for the formation of covalent bond. I don't know if I'm giving too much assignment. This that was one already. This two, it's just three. Okay, four. So it's not bad. Three limitations or shortcomings of the Lewis structure for the formation of ionic compound. Now I want you to know that there is a theory. We are still under covalent. Yeah. Before we go to metallic and eventually to intermolecular forces. I want you to know that there is something known as the valence share electron pair repulsion theory. Yeah. So I'm going to talk about this theory. The valence share electron pair repulsion theory. And I think we already had examples of covalent bond, benzene, dative covalent. We'll just go directly to metallic bond and eventually to intermolecular forces. valence shell electron pair repulsion theory. You can write it in full, not to forget. The valence shell electron pair repulsion theory. Valence shell electron pair repulsion theory. This theory proposes a 3D arrangement. When I say 3D, it means three-dimensional arrangement on an arrangement in 3 dimensions. For example, what we said about oxygen, for water, we said it can be represented like this. So it is with the use of this valence electron pair repulsion theory to get the shapes of covalent compounds. Yes, we know that this is how water looks like, this is how the molecule of water, this is how CO2. You even know the bond angle and so on. So it proposes a 3D arrangement of bonded atoms. In molecular theory or in molecular geometry. Okay, so this is the only thing I'll say now. The rest are in the notes, so I will not write these ones. This one is okay. I said this theory proposes a 3-dimensional arrangement for the shape of a covalent molecule compound. So now, according to the valence shell electron pair repulsion theory, the bonded atoms in a covalent compound, they will rearrange themselves to minimize repulsion. So what does it mean? It means that in this covalent compound, here is a linear arrangement. But the valence shell electron pair, they are repulsing each other too much. As a result, this molecule has an interest to reduce the degree of repulsion. As a result, there will be arrangement. And it will end up with what I put here like that. So according to the valence shell electron pair repulsion theory, bonded atoms in a covalent compound, they will always rearrange themselves in order to minimize repulsion. When they rearrange themselves, they form a 3D arrangement. And then the valence shell electron pair repulsion theory can propose the angle. So now I'm going to give some of the postulates of this theory. Number 1. I'll talk of the lone pair. I'll talk of the bond angle. Then I'll talk about the molecular geometry. Okay. Yes, a lone pair of electrons, I hope you know what it means. It means an electron pair that has not been shared in a covalent compound. So here, for example, I think we have a certain 2 electrons here, and even another 2 electrons here. Yes. So this electron pair is known as the lone pair of electrons. Why this one is known as shared pair of electrons? a lone pair of electrons, what does it mean? These are electron pairs that are not shared with other elements. Remember, if we are talking about ionic bond, there's nothing like lone pair and shared pair. Because they simply transfer. When you transfer, you forget. Yes, now, lone pair of electron comes in when some of the electrons that have been shared with other, this one you can share with this. Here I was just using two elements. You can share with this element, then share this particular electron with another element. You even share with a different element again. And at the end, there's a pair of electrons that you have not shared. But then you are already stable. That pair is known as a lone pair of electron, and the rest are known as the shared pair of electron. We have bond angle. The angle between the bonded atoms. So the angle formed by the bonded atom is known as the bond angle. And this angle, why is it that we cannot consider the other angle? And if there are other, the thing is, the angle that the bonded atoms forms with the central atom, which in this case is oxygen, this is the angle here, known as the bond angle. Because in a covalent molecule, there's always a central atom. And then at the end of the day, we obtain a three-dimensional molecular geometry, meaning that we can have a structure in 3D. Alright, I think the note is very clear in that. We have the T shape, we have the linear, we have the bend shape, we have the triangular shape, we have the triangular planar, we have the octahedral. Yes, so things are made easy with that. And then after that, another assignment is this. Using the valence share electron pair repulsion theory, predict the shape of BRF5, CLF3. Yeah, so here's assignment number something. Yeah, I think in the notes, this thing is done already, but still do it as assignment. We are done with covalent bond. Another part of covalent bond is done in organic chemistry as hybridization. We have sp2, we have sp2 and sp3 hybridization. So that part is going to be treated in organic chemistry. Metallic bond. Let's talk about metallic bond. Metallic